Oh wow, I'm definitely not gonna do good on this test.
I'm not gonna do well on it either.
We should study.
Together?
Yeah.
Okay, Sarito, so I'm gonna help you.
Okay.
First, we're gonna start with carbon bonding.
Mhm.
All right, so carbons have to have a maximum of 4 bonds, while hydrogens can have a maximum of 1 bond. A double bond involves the sharing of 2 pairs of electrons. So you see this, you have 2 electrons here, and then you have 2 bonds here, and you have 2 bonds here, and this is carbon dioxide. You can also have 3 bonds, and this is carbon monoxide. And then one of the most familiar and simplest bonds of a carbon bond is CH4, which is also called methane, and that only has 1 bond. And you see, this is the maximum. It can only be bonded to 4 different atoms. So you have 4 hydrogens around it. Next, we have hydrocarbon bonds. So hydrocarbon bonds are really simple because it's hydrogen and carbon bonding. So there's 2 very main types. So you have saturated and then unsaturated. So saturated has a single bond, while unsaturated has multiple bonds. And so for a reference, we have here ethylene, which is unsaturated. And if you see here, it has 2 bonds. So the carbons are bonded twice. Whereas you have ethane, which is a very known hydrocarbon, and this has only 1 bond to each atom, and that's called saturated. So saturated hydrocarbons are also called alkanes. The rules for naming alkanes. So the first rule is that you're going to find the longest chain, and the longest chain is called the parent chain, and this determines the base of the alkane name. And then when you find the longest chain, you're going to start at the end closest to any branch, which is usually the first alkyl substituent, and you're going to start counting from there. And you can count either forwards or backwards from that parent branch, but it will still have the same amount of atoms. And then for the third rule, you're going to use the appropriate name for each alkyl group, and that's supposed to specify its position on the parent chain with a number. And then for your fourth rule, when you have an alkyl group that occurs more than once, you're going to attach a prefix. So it can be di, it could be tri, or it could be so on when you're going to name the alkyl. And then the fifth rule is that the alkyl groups are listed in alphabetical order, and that does not matter based on the prefix. You're just going to do it alphabetical order, but you're not going to regard the prefix. So let's look at this image. So you have, if you look at your longest chain, you can count from many ways, but you notice that if you go this way, you only have 2, but if you go this way, you have 4. So you would start counting it either from this side going right, or you would start from here and you would go left. But either way, you would still have 1, 2, 3, 4 atoms in your parent chain, and this shows you that this is a butane. So because it has 4 carbons. And then you're also remembering that this is in the methyl group because there are 2, and then since there are 2 methyl groups, you're gonna attach di to it. So you're already at dimethyl. And since there are 2 groups, you're gonna number them both. So if you're starting here, the first group that you're gonna go is you're gonna go 1, 2, and then you see that there's another carbon attached. So here you would put a 2. But when you go to 3, there's also another carbon attached. So you would say 2, 3. And then you say 2, 3 dimethyl, and then you bring down the butane, and this becomes 2, 3 dimethyl butane. And that's the name. Then we move on to 2 other types of hydrocarbons. And these are not really hard to understand. All you have to understand is that alkenes have 2 bonds, whereas alkynes has a triple bond. So if you have ethene here, you have 2 bonds right here, and that signifies that it's an alkene, whereas for this you have ethine, and this has 3 bonds. And it's really simple how you name them. You just write ene at the end and as a suffix, and then you write yne as the suffix for anything that has a triple bond that's a hydrocarbon, remembering that an alkane, which is the simplest unsaturated type, only you would put ane. So it's very simple to know how to differentiate between them. For double bonds, you just put ene. For triple bonds, you put yne, and then for single bonds, you put ane. And then you also have to remember that when you are numbering the parent chain, you have to start at the closest end to the double or triple bond, because this is closest to it. And you remember,
here it is. This is a benzene ring. So this is the simplest form. It's just a basic benzene ring. All these are connected to hydrogens. So another way that we use benzene rings is to use it as a substituent form. So by doing this, we replace the hydrogen molecules with other molecules or groups. So for example, if we added chlorine, this would become chlorobenzene. So besides chlorobenzene, there's a couple other common benzenes. One of them is methylbenzene, but a difference is that there's also bromobenzene. Then we have phenol. So when we do that, when the benzene group is a substituent of a larger group of carbon hydrocarbon chain, then we can call this a phenol. So to name this, basically, we do what we've learned before that Adna taught me: 3-phenyl, and then 1-butene for where the double bond is. Okay, so now we're going to talk about alcohol. So alcohols are characterized by the presence of an OH group in the carbon chain, hydrocarbon chain. So basically, to name alcohols, it's really simple. So you select the longest chain of carbon atoms containing the OH group. So this would be the group. And this is the most crucial part. You have to number the chain so that the OH gets the lowest number possible. As I numbered above, it goes 1, 2, 3, 4, 5. Compared, you can't start from this side, so it can't be 1, 2, 3, 4, because then the OH would get 4 when it could just get the number 2. So that's crucial to remember. Always number so that the OH gets the lowest number. Then we obtain the parent carbon and we replace it so that the roots is OL right here, all. So you replace the E with all in the parent group. So just to name this, it would be 1, 2, so 2. And then, since this has 5 carbons, it's going to be pentane. So since it's an alcohol, remember to put OL. So this will be 2-pentanol. There we go. Aldehydes are part of the group called a carbonyl group. So that's a carbon double bonded to an oxygen. So basically, the ketone is the most general formula for this is this. And an example of a ketone can be, so we can name this by calling this acetone. And an aldehyde, it's also part of the carbonyl group, and the most general formula is like this. It's like this. We call this acetaldehyde. To name ketones and aldehydes, it's very simple. So when you do everything that Adna taught you earlier, by finding the parent chain and naming it, you take out the E, and for ketones you add O and E. And then for aldehydes you add al. So an example would be, say you got methane. You would take the E and replace it with al, so it would be methanol, which is another name for formaldehyde. And the same thing with ketones. You just take the E and you add ON. So say you had propane, you take it out and you add propanon, which is also another simple name for acetone. Can you guess what this is, Adna?
Is that a carboxylic acid?
Yes, you got it. So now we're going to be talking about carboxylic acids. So basically, they are acids that are characterized by the presence of a carboxyl group, which is COOH. And this is the formula. So C double bonded to an oxygen, carbon to bonded to another oxygen, bonded to hydrogen, and then this is usually the other hydrocarbon fragment. So basically, this is the really general formula, is RCOOH. So to name the carboxylic acids, you drop the final E from the parent alkane, which is, as Adna taught you yet again, and you add O-ic. So example would be, say we added a hydrogen to this. This would become methanoic acid, which also a common name is formic acid. And then other types are ethanoic acid, propanoic acid, butanoic acid, pentanoic acid. Pretty simple to get. Another thing we can also quickly learn about is esters, which have the general formula. So esters usually have a sweet odor, and that's very nice, and it contrasts to the disgusting odor of the carboxylic acids. And the general formula is right here, and as you can see, it differs from the carboxylic acid because instead of having a hydrogen here, it has another hydrocarbon group, and here.